Alright, space weather people, shut your yaps and fasten your seat straps. We got space weather for you here. The world's most comprehensive daily space weather show there. That's the sun there. We got three new sunspots over there in the northeast sea. So deal with that. And by the way, happy Labor Day. Hopefully you're not massively overworked and underpaid. Know what I'm saying? Yeah. There's some more composite imagery there from SDO, the Solar Dynamics Observatory. We'll tell you all about it and lots more here at the Smash News Network, least busted name in news. Like I said there earlier, 3 new sunspots over here in the northern hemisphere. There's 1, over here's 2, and up here's 3. See what I'm saying? Here's a colorized magnetogram. And before we take a look at things like volcanoes and earthquakes and sunspots and magnetic fields and so on, take a moment to do yourself a favor and press the subscribe button. If you're new to the channel, congratulations on realizing it exists. We're frankly surprised that you have, with the state of affairs on the internet these days. Thanks to our new subscribers. And let's move on to talk about volcanoes. Yeah, volcanoes. They're burning hot over here. Mount Abico's producing a 10,000-foot ash plume over Paramushir Island. It's a flight level 100. Luatolo continues to erupt in an effusive and explosive fashion. Don't set up your campsite at the base of Luatolo. Dacono, exploding flight level 080. It's an 8,000-foot ash plume. 21,000-foot ash plume over Popocatépetl in central Mexico. It has indeed calmed down in the past 24 hours. Fuego, not sure if it's erupting or not. Please don't pole vault the caldera. It could be unhealthful. We don't want you becoming part of the lithosphere. Nevado del Ruiz is exploding in Colombia, flight level 210. Sangay in Ecuador exploding, flight level 220. It's a 22,000-foot ash plume. 14,000-foot ash plume over Ravenador. 25,000-foot ash plume over Sabancaya, the world's largest volcanic ash plume there over Peru. And last but not, Villarrica. Strombolian activity continues there, ejecting hot fluid lava spatter and also water vapor, gases, and ash. Next, like I said before, shut your yaps. Now we're going to cover earthquakes. See, earthquakes. And it's been pretty chill over the past 24 hours. We'll cite quakes of a 5 or greater magnitude. The first of which was a 5.0 at Azerbaijan. That 5.0 was at 16:35 Universal Time yesterday afternoon. Now, like I said before, shut your yaps. The largest quake of the past 24 hours was this one right here. It's kind of in between Guam and Palau and Micronesia and Papua New Guinea, out there in the middle of nowhere in the Pacific Ocean. That 5.5 was at 21:29 Universal Time yesterday evening. So like I said, shut your yap in the state of yap. And that's it, I think. Those are the only 5 or greater magnitude quakes. So again, pretty chill for the past 24 hours. And let's, oh, no, I stand corrected. There was a 5.0 in the Molucca Sea. That was at 9:11 this morning on the 4th of September. It was at depth, a depth of over 100 kilometers. And now it's time to return to space. Space, a frontier. There's the closest star. Thanks for stargazing with us. And we only bring the world's most comprehensive daily space weather and most detailed solar imagery you'll find. Let's zoom in a bit here. So new activity happening in the northern hemisphere. There are a lot of plasma filaments on the Earth-facing portion of the solar disk, which we'll cover here momentarily as well. And let's talk some stats. So the 10.7 centimeter radio flux is still down at 131. Don't expect that to continue with new sunspots forming in the northeastern limb. I'll say the northeastern quadrant. There's really only one on the limb at this point. That is also the most likely place for large solar flares, which we'll show you here momentarily. First, the past year. Yeah, the past year of the radio flux here depicted by this black line. There you go. There's the radio flux. And the lowest levels we've seen since mid-April. Now, wait a minute. Is that right? Since the beginning of May 2023. So Space Weather Enthusiast Dashboard not forecasting any... Oh, they are forecasting a little bit of geomagnetic unrest later tonight. So no indication what it's from. Their Enlil spiral doesn't show anything like that, but hey. So some little minor upticks happening tonight, according to NOAA. NOAA argument from me there, I guess. We are expecting a possible minor CME impact sometime around midday or later on September 6th. So Wednesday we might see an uptick. I don't think anybody else forecasted that one. It was a pretty stealthy CME. And I think it has just a minor earthly directed component. Next, the past 4 hours of Earth's magnetic moment from space. This is our 4-hour geospace magnetosphere movie. It depicts magnetohydrodynamic pressure. The units it is showing here are nanopascals. Those are the units of magnetohydrodynamic pressure. And that's what Earth's magnetosphere looks like from about 12 Earth diameters. Next, Earth magnetic moment from the ground. And part of the reason we show this every day is because people are spooked and spooked and spooked. They're very, very spooked by a pole flip, by a magnetic excursion, by polar wander, etc. They're afraid that the poles are going to flip abruptly and that it's going to be spooky. However, this does not support that hypothesis. It's the past 4 hours of Earth's magnetic moment from the ground in nanotesla magnetic flux density. So we did have the CME impact or impacts. It also happened during a coronal hole high-speed stream, so that was kind of weird. And it's very hard to catch a signal when you have multiple events showing up at the same time. Here at the Smash News Network, Least Busted Name and News, we attempt to separate those and make sense of all that incoming data. The highest we saw was a KP 5.67, so NOAA nailed this one. Although the first impact did show up, really the first impact was actually, this is a coronal hole high-speed stream. So the two CMEs, I believe they are right here. And they were pretty weak signals. So there's the first one, there's the second one, and this was a coronal hole high-speed stream, or HSS. So that just had to do with magnetic fields. CMEs struck during that coronal hole high-speed stream. It was pretty much a dud. But hey, you've got to over-forecast a little bit, folks. That's just the way it works in meteorology and indeed in space weather forecasting. So we're more like NASA in that we want to forecast every CME impact. We're less concerned about false positives than NOAA, because NOAA, it costs a lot of resources to get ready for satellites to be struck by incoming space weather. Astronauts are more important than satellites, so NASA wants, every CME impact forecasted. So anyway, current conditions are quite nominal here for the solar wind. Solar wind speed here just below 6 protons per cubic centimeter. Solar wind density, solar wind velocity here. Solar wind density just below 6 protons per cubic centimeter. Solar wind velocity about 400 kilometers per second. Pretty unremarkable. GOES magnetometers here, same thing. They'll be smoothing out in the coming day or two as the plasma that did show up in the Earth system is now reaching static equilibrium. So you can expect the GOES magnetometers again to smooth out. If you look at the 7-day graph, you see smoother curves over here when there is no space weather going on. You can expect that to return. Even if we do see a minor CME impact, that will cause some perturbations in the GOES magnetometers. Next, our top view ecliptic plane field plot, and this is just some fantastic data here for you. Sector boundary crossing coming in a few hours here. So if you look at the final image here, there is a South Pole current sheet headed this way, and it could be here really any moment, actually, because again, like we said repeatedly, sunspots in the northern hemisphere are accelerating that South Pole current sheet. So yeah, barring some massive sunspot rapidly forming in the southern hemisphere, South Pole current sheet could be here any moment. Keep in mind this data was already 9 hours old. Geez, that's exceedingly old. So anyway, I reloaded it, and I suspect that Earth may already be in a South Pole current sheet. So it's not really a big deal, but sector boundary crossings do matter, as the plasma from the sun is polar. It is oriented to one of the sun's polar fields or the other. So we're expecting South Pole plasma showing up now, or soon. Here's our line of sight field plot as we transition to coronal holes and sunspots, which are sort of the two main features that you'll see evolving during a solar sunspot cycle. So let's move to coronal holes. So let's see, what do we got? Some South Pole oriented coronal holes here making their way in the southeast, and as well as around those new sunspots there. So getting some sunspots and coronal holes in close proximity to each other. And let's take a look at the view from SDO's 211 angstroms. There is the best wavelength through which to view coronal holes. Coronal holes are super important to the solar cycle in that they show us the solar polar field reversal process. At solar minimum, coronal holes hang out at the poles. And around solar maximum, you'll see lots of coronal holes across the equator. So those are the most geo-affective type, and we've really been seeing a shortage of coronal holes throughout this cycle. Don't expect that to continue. And let's move on to sunspots. So the next move is, yeah, sunspots. We've got some new ones, 3 new ones. So there is a new one right there. That one's already got a name. That's 3421. However, here is another new one. That'll be 3422. And here is another new one. That'll be 3423. Now, with the setting of 3413, and now it's moving mostly out of sight up here at the northwestern limb, the most likely place to see a large solar flare is now at the northeastern limb. There are huge plasma filaments there, as well as a beta-gamma class, at least beta-gamma class sunspot group. Let's take a look at sunspots close up from the SDO continuum. So there you go. There's your zoomed-in equatorial view. Some evolution happening to this group down here. So a significant uptick there in the northeastern quadrant. Next, SEPs and solar flares. The ghost proton flux here returning to baseline levels following a minor SEP, solar energetic particle event there. No big deal. Caused a little bit of polar radial blackouts, and check it out, we've got a flare happening as we produce the video. So it's a C6.66 class solar flare, so that's something you can be spooked about. Perhaps that flare was caused by the Illuminati or CERN. Ha ha ha, just kidding, folks. Pardon my sarcasm. Humans are not controlling Earth's weather, much less space weather. And that flare is coming from the northwestern limb once again. So that's where all the action has been in the past few days. And check it out, here is a fantastic view. That is the SDO 94 angstroms wavelength. And we'll also show 131 angstroms. That is the other wavelength through which to view solar flares. Keep in mind those are not X-rays that we're viewing there. That's extreme ultraviolet. The SDO 131 angstroms wavelength are the ultraviolet emissions of extremely hot ionized iron gas. In other words, that is iron star. And moving right along, we're going to encourage our viewers to look up. If you're doing so at the morning sky, you might see something like this. That's our star chart from skyandtelescope.org. If you're looking at the moon, you might see Jupiter very nearby, the third brightest object visible in the morning sky, as well as the sun peaks over the horizon here. Mercury now becoming an evening celestial body. If you've got a low horizon, low light pollution, and clear skies, you might be able to see Mercury just after sunset. Here's your solar system forecast. There's where things are today. Let's advance it 1 week. We will have a crescent waning moon on the 11th of September. Next, our astronomy photo of the day, featuring two awesome nebulae from the constellation Cygnus. This one's called the Soap Bubble Nebula, believed to be a planetary nebula there with a sun-like star at its core. And if we move over in this direction, whatever direction it might be, another nebula here in the constellation Cygnus. This one a little bit more violent. This one is more like a, well, it's not considered a supernoval cloud because, like all supernoval clouds, it has a star in the middle of it. So it's a hyperactive Wolf-Rayet star, which is a type of blue supergiant, and they are very rowdy stars. They have a lot more output. They're hotter, they're big. They're rowdy stars, Wolf-Rayet stars, folks. I suspect we're looking at hydrogen and oxygen there in the red and blue wavelength respectively. That is a very dense nebula indeed. So there you go. The Soap Bubble Nebula and the Crescent Nebula, located in the constellation Cygnus. It's a very busy part of space, as you can see, quite a few background stars there. And let's move to coronal mass ejections. Here are 104 frames from yesterday, and a few events happening there. We don't anticipate those to be earthly directed. Although, like I said earlier, we are expecting a minor CME impact sometime around midday on the 6th. Here are today's frames, an additional 43 frames from today's September 4th. And it's been pretty quiet so far today. Here's Soho Lasco C2 and C3. Let's maximize those at the Integrated Space Weather Analysis Center. So don't expect the low number of CMEs to continue, folks. There are a ton of Earth-facing filaments, which we're going to show you here shortly. First, we'll show stereo A along with its difference imagery. It is located quite in line with the Earth here at the moment. It is moving to the west. So that would be in this direction, if you're wondering. The west, where sunspots set. Anyway, there's stereo A, the raw coronagraph on the left, and the difference imagery on the right. And fortunately, we will soon get a little bit more angular data there from stereo A, so that'll be great. And let's move to filaments. Yeah, filaments. There are a big time number of filaments on the Earth-facing portion of the solar disk. And like I said, those are the kind of things that can turn into coronal mass ejections. Those plasma filaments are disobeying gravity and being suspended by the sun's powerful magnetic fields. And look at all the filaments. It's still an insane number. I mean, you've got 1, 2, 3. Let's stop that. Stop that. Stop that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that's only one. 11, 12, at least 13 filaments on the Earth-facing portion of the solar disk. So that's a lot of filaments. Here's the grayscale view as well. We show it also because it shows also prominences, which are just the same feature hanging off the edge of the solar disk. There you go. Lots of prominences, especially in the northeast, which is rapidly becoming the most likely place to see a large solar flare. And let's cut to our SDO. There is SDO 193 angstroms. Certainly some great views there of plasma filaments. It's also pretty good at showing coronal holes in active regions. You may see some activity right in the center of the solar disk there. That was a radio burst, but it wasn't really associated with a coronal mass ejection as far as we can tell. So a lot of times the plasma will stand up and then splash right back down. I think that's what's happened there. It just basically reoriented itself. And yeah, lots of filaments facing Earth at the moment. We'll also show 304 angstroms because it is also fantastic at showing filaments. It's also good at showing flares. The ionized helium wavelength there from the Solar Dynamics Observatory. And again, I think the most likely place for a large flare moving forward is going to be in the northeastern limb, which would be your upper left. I think there may be also some additional sunspots there behind that new sunspot group, as I see some evidence of strong magnetic fields over there. So we'll close out our SDO imagery sections with the 171 angstroms plus colorized magnetogram. It shows you the polarity of those organized magnetic fields, as well as the what we call the quiet corona, the lower portion of it. That's the 171 angstroms depicted here in a greenish gold color. By the way, join us over on Twitter if you haven't already joined over there. I mean, I don't know, if you've unplugged entirely from social media, we don't blame you because it is truly pathetic and the censorship continues in a truly ridiculous, un-American, and criminal fashion. However, if you'd like to see our auroral imagery that we've shared, you'll have to do it over there. Also, if you want to name filaments after living people, do it over there at Twitter. Follow the hashtag #NameThatFilament. Here are the past couple of hours from the GOES 16 SUVI, and it looks like a CME is jumping off. So check it out, a prominence happening right over here. That one certainly looks like it's going to eject some material. So another event here, not only a flare, a C6.66 class solar flare, but also a CME happening as we produce the video. And you can also see some activity up here in the northeast. Again, expect that to be the location for large solar flares moving forward. Let's get the bonus features segment here, starting out with satellite charging hazards. We have some minor ones in the eastern Pacific. GOES electron flux here has come up as NOAA forecasted, something you often see following a coronal hole high-speed stream, and indeed we did. That's the one-year graph of the greater than 2 mega electron volt electron flux, and the model is now for it to level off here after rising a little bit at the next update. We'll also show the layer where that's measured. The electron flux is measured from way up at 22,000 miles of altitude using radiography by the GOES 16 and GOES 18. Here's the vibrational frequency of that layer, the F layer of the ionosphere. We are seeing lots of low-frequency anomalies happening at the F layer, which is what you would expect. However, that will subside shortly. A little bit of incoming plasma, a little bit of low-frequency anomaly. It's quite normal indeed. If you're spooked of this, you shouldn't be. It's looking like it has for years and years. By the way, we've been making these space weather videos for over 6 years now. So a lot of red on that. That's the low-frequency anomalies. This depicts anomaly in megahertz from the 30-day median. It is from the Australian Government Bureau of Meteorology. And them are the facts. We also like to show the total electron content because it's useful for Earthlings as well as Spacelings. Total electron content is free electrons to about 12,500 miles of altitude, and here it is on a worldwide scale. The coupled thermosphere, ionosphere, plasmasphere electrodynamics model. When your GPS satellite communicates with your handset, it must communicate through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt sometimes, the inner plasmasphere, and then the ionosphere. When that includes a lot of free electrons, charged particles, then you get signal refraction. At the moment, not a lot of signal refraction happening here. Things are very organized. So, very organized total electron content there. The electrons are right where you'd expect them to be for the most part, around the equator at noontime. GPSs should be working quite well, and quite normally. If you're spooked of a pole flip, this is another reason you shouldn't be spooked of a pole flip, because the electron contents would be all over the place. But they're not. So, I mean, what else can you say? Your GPS works. It's an indication that the electrons are where you'd expect them to be. Here's the anomaly from the 10-day average over North America. And also not spooky, not scary. No major signals showing up there. And cheers. So here's the latest intensitygram, latest colorized magnetogram. Let's take a brief look at these new sunspot groups. That one is beta gamma. All right, let me do that again. That one is beta gamma delta class. So it's got the ability to produce large flares. This one here is beta gamma class at the very least. And let's check out this new group. We've got all three on screen. Perfect. So this new group up here is beta gamma class. So we do see some plasma dancing around up here behind the northeastern limb though. So again, most likely place for a large solar flare is rapidly becoming this area. So this area over here is expiring, and this area here is conspiring to produce large solar flares. Which brings us to our meteorology segment, as we're going wave chasing, and then we're going to look at sea surface temperature anomalies, because the seas are very calm, folks. Very calm. Now, maybe you're spooked of calm seas, I don't know, because of the calm before the storm. But at the moment, there are no big waves anywhere. I think these are the largest waves in the world here, only 24-footers in the South Pacific near the Southern Ocean there. That is no man's land. There is nobody hanging out down there. So we've got some lows in the Atlantic. They're producing smaller waves. Again, it is smooth sailing around the whole planet at the moment. So let's take a brief look here at sea surface temperature anomalies, because this is another thing pole flip enthusiasts are spooked about. Oh no, look at, there's going to be cold water coming through here and going into the North Atlantic and shutting down the North Atlantic Oscillation, except there's not. Melt season is about over, as Greenland is putting on feet of snow at a time. So that's not a very good theory. This depicts surface winds and sea surface temperature anomalies. Let's just show the planet here. There is the Arctic Ocean, which has a whole ring of low sea surface temperature anomalies there. And then around the northern Asian continent and northern central Europe, you've got very, very hot water. North Atlantic, almost entirely hot water. Except in here, where it's quite cold, actually. About 4 degrees below normal. Southern part of the Atlantic Ocean, mostly anomalously on the cool side. Indian Ocean, a mix, pretty average temperatures in the Indian Ocean. The Southern Ocean, a mix. And the Pacific, we've got to zoom out to show the whole thing. There's the entire Pacific Ocean, basically 1/3 of the planet there covered by the Pacific Ocean, and a significant mix there as well. The northern part anomalously warm, the area around Hawaii anomalously cold, the equatorial portion anomalously warm, and the southern portion a mix. So that's what's going on as far as ocean temperatures. And I'm sure those of you who live at the ocean can verify that sea surface temperatures affect your weather, wouldn't you say? Anyway, here are the winds for the eastern world. Shut your yaps. Here are the jet streams for the western world over here. Powerful anticyclone here showing up as we have a trans-equatorial jet stream turning into an upper level high. Counterclockwise rotation in the southern hemisphere is an indication of that. Here are the central world's jet streams. Surface winds. Surface winds of the west. And let's don't forget jet streams. Anticyclone here over the northeastern Gulf indicates clear skies over the Florida Panhandle. Hopefully that'll help dry things up. Next, looking at pressure, and guess what? There's a low right in here, which is going to hightail it toward the Leeward Islands. We'll show you forecasts in a minute. That is the mean sea level pressure from windy.com. And here is clouds and fog over the Americas. So at nighttime, we like to use a shortwave radiation map. It shows clouds and fog at night. Why? Because clouds emit infrared radiation. And so we can, quote, see them using the shortwave radiation satellite. It's too dark over like half this map for the visible, so we use that. Next, our weather.gov map. If your location is lit, please head to weather.gov and get your own weather alerts. Flood watches there over much of Nevada. Weather.gov, and here comes some forecasts. So you can see this low here. It's rapidly making its way toward the Leeward Islands. That's our North Atlantic pressure and precipitation forecast. And let's move to the lower 48 forecasts. Here is pressure and precipitation for the GFS 72-hour model for that. Okay. Here's the GFS 72-hour total accumulated precipitation forecast. Got it? Heavy rains there coming to Wyoming, Montana, and especially North Dakota. Next, the jet stream forecast. Mankind doesn't control the weather, but the jet stream does. Typically, it causes weather systems to move from west to east. But when you get meridional jet stream flow and it's flowing north to south or south to north, then you get different types of weather patterns. The jet stream, it really is control of your weather, not mankind. Chemtrails, contrails, weather engineering, weather modification, HARP, etc., cloud seeding are not controlling large-scale weather patterns. Next, the GFS 72-hour temperature anomaly forecast in degrees Celsius. Major heat wave coming to the northeast. So it was hot yesterday. It'll continue to be likewise in the Lehigh Valley. Next, our lightning mapper. That's where lightning has been striking. Let's check and see where lightning is striking. Next time you hear thunder, check out lightningmaps.org. And no, the universe is not electric. No, electricity does not govern cosmology. No, lightning bolts are not moving galaxies around. There's the full globe view there from lightningmaps.org. And by the way, if you enjoy the content, consider supporting the channel. One of the best ways to do that would be at the Smash Team site at smashomash.com/SmashTeam. We launched our own subscription services site because it's just superior to Patreon. So if you want additional content, support the channel over there. You can join at the bronze level. That'll cost you $0 per month. We even send out email alerts for videos just like this one. There's also a silver and a gold level if you want additional content. Join at one of those. You can find links there as well as below this video to our Hemp Lucid shop. Today's featured product is the Focus Mushroom Gummies in Grape, which is actually what I have. There are the ingredients for you. So if you are looking for something tangible to support the channel, consider visiting our affiliates/sponsors as we endeavor to keep this channel in existence, publicly visible, and free for all to view. Check it out. There's a sale going on, not only on the Anchor battery backup, save 15% on the 256 watt-hour solar generator. So that can help you out. Run some stuff if your power goes out, or take it camping. Don't try to run your hairdryer with it. It's not going to work. However, it does have 256 watt-hours there. 15% off. Amazon.com/shop/smashomash to see more of our camping supply suggestions. You can also find links at smashomash.com, the homepage. The official homepage of the Smash News Network, Least Busted Name in News. All kinds of links there. You can find original music on Spotify from our record label Golden Cat Productions, the Hemp Lucid link, and lots more. Perhaps follow us on Instagram for things like lifestyle and fitness posts. Those come up on the regs. Most days you'll see updates there. So help us out with clicks. If you're unable to open your cobweb-encrusted wallet, and send us a few bucks by becoming a member of the Smash Team. By the way, today is Labor Day, which features an interesting local race. It's kind of like a mass start time trial known as the Donut Derby, run by the Valley's largest cycling club, the Lehigh Wheelman Organization. For every donut you eat, you save 3 minutes. So you win the race by having the fastest donut-adjusted time. Now, when I do this, I don't eat donuts. However, when I do it like a time trial specialist. So let's just say I do the course kind of at a high speed. I've been known to do such things, folks, but this year not participating. So stop at 2 different donut stops there at mile 12 and mile 24. The Lehigh Valley, one of the world's most prevalent and best cycling communities. If you're coming to visit us, also stop by the Velo Shop. Yeah, the veloshop.net. Put in your email online here to save 10% for your in-store purchase when you're coming to visit. If you do visit Becky and Don at the Velo Shop, make sure you tell them Dan, a.k.a. Smashomash, sent you. It's our official UCI trade team. Today's featured product from the Redbubble Shop is 40% off. Yeah, 40% off. Can you believe it, folks? 40% off with the promo code You Deserve It. Today's featured product is We'll Keep an Eye on It. So this is one of the requests from one of our viewers. Have you picked up any yet? Regardless of whether you pick up any, we'll be keeping an eye on it. And when I say ion, well, you get the idea. 171 angstroms depicts ions, ionized iron, as I said earlier. So there's an ultra high-res image of it. That's like 5,000 pixels, by the way. You can see all kinds of features and depth in those SDO images that we have up there. The We'll Keep an Eye on It product, 40% off, along with everything else at the Redbubble Shop, linked both below this video and at the homepage. Help advertise the channel. It's got the YouTube URL on there and everything. We'll be keeping an eye on it. And when I say eye on, well, you get the idea. We'll close out with Doppler radar, clouds and fog, and water vapor. So let's do it. Here's the recap. There's vertical motion in the air column. Ground-based systems known as Doppler radar. There is shortwave radiation emitted by clouds. It shows clouds and fog even when it's dark. The NASA GOES Interactive Weather Satellite Shortwave Radiation Map. And there's the water vapor map, which shows all the water vapor. When your Doppler's unclear, try the water vapor map. If you understand atmospheric physics, you will be able to forecast your own weather. It's not that hard, folks. You've got plenty of information. So anyway, thanks for tuning into the Smash News Network, least busted name in news. Pardon all the controversial facts that we cover daily. I know it's very, very controversial, citing facts in the year 2023. I'm going to head back to the bunker. That's why I'm not doing the donut derby. And while I'm gone, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Whoa!